Welcome. In this video, I'll be showing the transform component within Unity. Let's get started. So what is a transform? Let me show you first. So create a new 3D object. Let me create a cube and I'll focus this in scene view. So you'll see if I close all the other components, and the first one right here is the transform. It's the position, rotation and scale of a certain object. So any object that you create will definitely have a transform on top. Even if you create an empty object, you'll see that transform is default within the object. Even when you try to remove it, so for example, you don't want to transform, you cannot do it. If you try, you'll see there's nothing here. So if you want to remove any other component, you just simply click the 3 dots and remove component. But for the transform, it is compulsory, basically locked onto each object that you cannot remove. It is permanently stayed on. So in this video, I'll be teaching you each part of the transform, so the position, rotation and scale, and how you can utilize it within code. So how you can modify each one of these and how you can use it. So let's get started. So the first thing you want to do is create a new script. I'll go create and a new C# script. Let me just create this transform. There might be a problem where you try to create this because there's already a class or like a function in Unity that's called transform, so we might want to name it something else. For example, I'm gonna name mine player script for now. I'll name mine player script. This won't be conflicted with anything within the Unity registry basically. So double click on the script to open your code. Once you've opened your code, we just want to set up a few variables to get us started. These are all the variables we're going to be using in this tutorial. So we're going to be setting a transform. It's basically getting the transform of the object and saving it into a name called transform. And same with these, saving it into a vector called position, and this one is a bit special. It's probably the most complicated mechanic in all of these, or maybe even the whole of Unity. But don't get me wrong, there's much more complicated stuff than quaternions, but this is definitely one of the most complicated. And we're saving it into a variable called rotation, and we're just simply setting that to it. So you'll see transform the position, transform the rotation. This is what I want to teach you mainly, is the dot. So every time you code in C# or in Unity, a dot basically separates it to the next level. So if I go back into Unity, let it compile for a bit, and for example, what I'm doing is getting this variable called transform, and then dot is going the next level down, dot position, dot rotation, dot local scale. If I go back, it's getting a transform variable, so let's connect it up. So connect the script and you see a blank transform. What we want to do is simply drag it in. Now it's connected into the script. We can use this to modify what's happening over here. Back in our script, I've done something very similar in the past videos where I modified the position and the scale and rotation using a vector, and also rotation using a quaternion as shown here. But this video is just showing you the even more basics if you got confused within that video. So what I'm gonna do now is simply do the same thing I did in the other video but in more detail. So what is happening right here is basically we're establishing the variable and we're saving a value to the variable, and as you can see here, we're saving transform.position. And in Unity, I often think it like this. So the dot in Unity means the next level down or the next thing in the list. So transform dot position dot x, y, or z. So it's going one level down each time you press dot. So for example here, transform dot position, it's getting transform dot the position. Same for the scale and rotation, but for rotation it's saved into a quaternion instead of a vector 3. And difference between vector 3 and quaternion is that a vector 3 is 3 values, so x, y, or z, and a quaternion is basically 4 values, x, y, z, and another one named w, so x, y, z, and w. It's a bit different but it's around the same concept. And if you wanted to understand quaternion fully, it's one of the most complicated subjects within Unity, so it might take some time for you to get your head wrapped around. I'll try my best to make a video on it in the future, so keep an eye out for that. So now that you get how this works, so it's basically getting whatever the component is and then the next level down. So simply transform dot position, and saving it into a position that is a vector 3. And what we want to do to the value, we want to edit it, we want to change the value. So next down, you can see in the update, I've made two nodes, change value and then modify value. The difference between these two are, for the first one, we are only changing it, but we're not actually sending the data back into Unity for the cube to move. We're simply changing it and nothing's happening. For it to actually make a change, we need to make sure it sends back into Unity. So modifying it, not just changing it. So modifying, so changing this to make sure the cube moves. So for change value, what we want to do is get a position or get a value and modify it, exactly what it says. So position.x is getting this. If you remember, it's saved into a vector 3, which x, y, and z, which is exactly what's here. So transform.position, it's saving x, y, and z into a variable called position, and we're getting the x value of that position. So x value of that position. So for a vector 3, if you want to do dot, the next level down is basically 3 values. The first value is x, the second value is y, and the third value is z. It doesn't necessarily mean that x, y, z of this component. If you wanted to move the next level down in that component, you have to specify which component it is, which is the transform, next level down dot position, and the next level down dot x. So for this one, we're just gonna do position.x because that's the first value anyways, and we want to move the cube in the x. So if we zoom up into the scene view, and you'll see that the red axis is the green the x axis on the top right here. Let me just change this, and we want to change that so the cube moves in that direction. How do we do it? So we get the x position first, and we make sure it is changing by whatever value we want. So the current position of x is equal to the current position, so whatever this position is right now. So the current position plus a value we want. So sorry, I just deleted that position. I'm just gonna add 1 for now. So position.x plus 1, and it is getting the current variable and adding 1 on top each time. Now next, we want to actually modify the value. How do we modify it? We take the transform.position. So we take this out and then we physically change it. So what we want to do, we want to take the transform.position, so we're taking it out and we're making it equal to simply the position and put a semicolon. So remember, this is only changing the first value of position, which is equal to a vector 3. So it's out of 3 values, and to change a position, you need to pass in a value that's constantly changing. So that's exactly what we're doing. We're changing the value and then we're modifying it. Let's save this and go back into Unity and see what's gonna happen. And you'll see that the cube immediately zooms off into the horizon. That's what we're expecting, because we're changing the value by 1 each time the update is run through, and it runs through many times per frame. So you see it goes straight into the horizon, and we're just simply modifying the value over here. Now next up is the scale. So you can do the same thing, just simply change this to scale. Oh, there we go. Scale, if I can spell correctly. Position, scale, and for this we'll just simply do transform.local scale is equal to the scale variable. but for the value I want to make it 0.01 because it's changing it quite fast. Or let's make it 1 then. Actually no, I'll name a public. I'll change this because we don't need this. My fault at the start. Sensitivity. I will simply put that as sensitivity. There we go. Get rid of the extra semicolon. And will it stop lagging, please? Save it. Go back to Unity. You'll see an extra field for sensitivity. We want it to be pretty small, so 0.1. Let's see if it works. You'll see that the cube just slowly expands, like slowly ever expanding, because I changed the value to 0.1. If it was 1, it would be zooming off into the horizon. Like the expanding speed of the cube will be the same as the cube just running into the horizon. So if you wanted to see, this is what it will look like. It's gonna grow pretty fast. Yup, just starts zooming straight away. If we change it to 0.1, we can actually see how it expands out, just slowly expanding, and you can do it to multiple values at the same time. So for example, I want to copy this, and on the next line I'll change the Y as well. So change the Y, and we'll just simply, and yeah, there we go. That's all we need to do. We're just changing the value. Since it's already saved into this, it's just the scale and we're changing it. We don't need to change anything else. So you'll see the cube expands out like a wall. You can use this for an object in the game where you want it to quickly grow when it gets spawned, like a shield or a wall or something. You can change this value to a pretty high value, and you'll see it booms up, so it zaps up. That's kind of the effect you want in like an action game or something, but I'll keep mine at 0.1 for showcase purposes. And for the last thing, you can modify it, which is the rotation. It's a bit complicated since it's related with quaternion, but I'll show you a formula and a method on how you can modify this quaternion and rotation. So for the rotation, I'm just going to briefly explain what's going to happen, and I'm going to make a part 2 to explain it in more detail. So the formula I promised you is basically a distance formula. So the position that we want to face and our current position. So for quaternion, we want a position for it to stop rotation, like for it to stop rotating, or a direction for it to look at, and our own position basically. So we can just do transform dot position. That's our own position, so we want the target dot position minus our own position, which is basically the direction to look at. You see the red lines because I haven't set any of these variables here. So let me quickly transform. I'll name it target pose, and that's gone. And target, and the public, no, for the direction to look at, I'll simply just set a private variable named the same thing basically, just this one is going to be a vector 3 direction to at there. So that's what we want to do. This is basically getting the position we want to look at, and I'll write a simple script to show how this is going to work, but I'll explain it in detail in part 2. So now we have the direction we want to look at. What do we want to do to it? We want to make it so that it faces direction. So we want to pass it into a quaternion dot look rotation, and we'll pass in direction to look at, and that's basically turning that into a direction we can look at. And then I'll put final rotation in the end equal to that, and I'll put another private direction. Oh my god, okay, a private quaternion called final rotation. That should be gone. And in the end, what we want to do is same as before. We want to modify it, so the thing will be transform dot rotation is equal to final rotation, and this is basically gonna look at whatever we try to pass in the value. So we'll select a second object for it to look at. So the target, we want it to be this empty game object, and dragging the empty game object in here. When we run the game, this cube should look at the object. See, right now the object is right here, the cube is looking at it. Let me show you in more detail. I've done this before in another video where I tried to create a enemy system where the cube always goes towards where it's looking at. So right now you can see the cube always looks wherever this object is, because it's getting basically the position from this to the cube itself and looking towards this direction. If you get confused by all these code, don't worry, I'll be explaining it in much more detail in the next one. So that's gonna be basically it for this video. I hope you enjoyed, and I'll see you next time. Bye.